So I'm going to talk through some of these questions. So for number 1, give the linearization of f of x equals 1 plus square root of x. So this is number 1. So the function is square root of 1 plus x. And we need to, so we're going to use this near x is equal to 8. Okay, so in other words, I want to find the line that's tangent to this function at x is equal to 8, and we're going to use it in that neighborhood. Okay, so then we need a point, so f of 8 is 3. We need a slope, so we need to take the derivative. So this is going to be 1/2, 1 plus x to the negative 1/2, and the derivative of the inside is just 1. So our derivative is 1 over 2 square root of 1 plus x, and now let's take that derivative and plug in 8. So that's going to give us 1/6. So the equation of our tangent line is y minus 3 equals 1/6 x minus 8. And I'm going to use that to approximate a y value. So in fact, I'm going to isolate the y. So this becomes 3 plus 1/6 of x minus 8. Now we're looking to approximate the value of 9.1. So what would we need to plug in for x? Well, that's like finding f of 8.1. Okay, so f of 8.1 is going to be approximately equal to this. So 3 plus 1/6. And if x is 8.1, this is going to be 0.1. So that's just going to give us 3 plus 0.1 divided by 6 gives us, so f of 8.1 is approximately 3.01, let's say 3.017. And I'm going to do the same thing with question number 2. We're looking for the equation of the tangent line. So our function is f of x equals x over x plus 1 near x is equal to 1. So if we're writing the equation for a tangent line, we need a point. So f of 1 is going to give us 1/2. We need a slope, so we need to take the derivative. And I'm going to use the quotient. Derivative of the top is 1 times the bottom is x plus 1 minus the derivative of the bottom, 1 times the top, over x plus 1 squared. So this is just giving us 1 over x plus 1 quantity squared, and I want that derivative at 1. So that's going to be 1 over 2 squared, so that's 1/4. So then the equation of our tangent line is y minus 1/2 equals the slope, x minus 1 times x minus 1. So I'm going to write this as y is 1/2 plus 1/4 x minus 1. And we're going to try to approximate f of 1.3. So that's going to be approximated by this tangent line. So we'll have 1/2 plus 1/4, and 1.3 minus 1 is 0.3. And that's going to give us, so we have 0.5 plus 0.3 divided by 4 gives us approximately 0.575. Now, I'm going to go back and test the actual values. So the actual value is, in this case, f of 8.1 is really the true square root of 9.1, which is 3.0166. And this is our original value. This is our real value, and they're pretty close. I'm going to do the same thing over here. So the actual is, let's see, if I take 1.3 and plug it in for x, that's 1.3 divided by 2.3, which is going to give us 0.565. So it's, what, 1/100th off.